Here's our lesson 12.3 geometric series. I'm going to let you know I'm having some technical difficulties, so if something doesn't show up right, I'm sorry. We want to read our question. So today we want to figure out, how do you find the sum of a finite geometric series? So sum right here, remember sum means we're going to be adding. Finite is going to be a set amount. So today we're not going to talk about things that go on forever, patterns that go on forever and ever and ever. We're just going to be talking a set amount. So it could be like we're doing our even numbers, 2, 4, 6, 8, 10, but instead of going on past 10, we're just going to stop there at 10. And then geometric, remember geometric, we're going to be multiplying. So actually, the example I gave you is not a very good one. There is one important formula that you need to know for today. So we're going to write that right now and talk about what the pieces mean. So our formula is written as S of n, where S is going to mean sum. That's why we write it that way. We're not writing an equation. We're going to be adding some things together. Equals A. Remember, A is our what we call the starting value. They just put it as A in the equation. And we've got a big fraction. The top of our fraction is 1 minus r to the n. And then on the bottom, we've got 1 minus r. So the r right here is going to be our ratio. That's our pattern, what's happening every time. And then n is however many terms there are. So n is the number of terms. You do need to know what all of those stand for, or else we're not going to be able to use this formula to do anything. All right, let's look at an example. We're going to do two examples. So remember, there are three things that we need to know every single time. We need to know A, we need to know R, and we need to know N. So remember, A is our starting value. So if we look here, our starting value is 1. R is the pattern that's happening every time. So if we kind of break this apart and think about these as separate numbers, if I look at what's being multiplied or divided, this is being multiplied because it's getting bigger, and it's being multiplied by -2. So that's my pattern. So my ratio is going to be -2. And then n is the number of terms. And if I count here, I have 1, 2, 3, 4, 5, 6 terms, so n is 6. All right, so my formula is pretty easy. I've got S of n equals my starting value, 1. And then we're going to do our parentheses. 1 minus r, which is, here I'll write what I'm plugging in a different color. 1 minus r, which is -2 to the n power, n is 6, over 1 minus -2. So compare this, take a second to compare this with the equation you just wrote above, and notice I'm just plugging in the three numbers into their respective spots. Everything else is the same. Okay, now I'm going to use my calculator to do different parts of this at a time. So the 1 is going to stay the same at the front. I'm going to do just the top part of my fraction. So I'm typing this in my calculator. I am going to use parentheses, so you may want to make a note to yourself that you do want to type the parentheses with the exponent on the outside. So make sure the exponent is up there on the outside. When I did that in my calculator, on the top I got -63. And then on the bottom, you don't even have to use a calculator for that. That's going to be +3. And then all we have to do is just work that part out. That's a lot simpler. So if we had a number, we could divide first in our parentheses, and that gives us -21. And then we could just multiply, and that's going to give us -21. So that means the sum, we can rewrite that, the sum equals -21. That would be the answer to that problem. All right, the second problem, we want to try to start in the same place. So we've got we need to find A, R, and N. So our A value here, that's where we're starting, that's 1/2. Notice that the sign is changing, and I've got fractions here, and it's the bottom that's changing. So that means this is a division of sorts. So my change is dividing by -2, or we say multiplying by -1/2. And then n, now that's the part that we don't have. We don't know how many terms there are, because if you notice, you've got ... here. So to figure that out, we may just have to use our calculator to keep calculating what the next one will be. So we've got 2, 4, I'll just kind of make a note on the bottom, 2, 4, 8, 16, 32, 64, and then 128, and then 256. So if we count, I'm just doubling the denominators. If we count, that is 1, 2, 3, 4, 5, 6, 7, 8 terms. So for n here, we have 8 different terms going on. All right, now we want to set up our formula. So S of n equals our starting value, 1/2. And we've got our big parenthesis, 1 minus -1/2 to the n power, which is 8, over 1 minus -1/2. All right, so now we're going to use our calculator to do some things. Remember, we want to do the top separately, so I'm going to type that into the top of my, I'm going to type the numerator into my calculator. And this is going to seem a little funky. I got a really big fraction. All right, so the top of my calculator is going to say 255 divided by 256 over, the bottom fraction is going to be 1.5. Now, the reason I didn't write the top as a decimal is because it was a really crazy decimal, and this fraction is more accurate. So now in our calculator, we actually do want to divide this whole fractional part. And to do that, you have to use parentheses around the top and then divide by 1.5. All right, so now my equation says I've still got my 1/2 here in the middle. This whole fraction on the inside is now 85 over 128. And now we're just multiplying, and you all actually know about fractions, you just multiply straight across. So this is going to be 85 over 256. And that is the sum of the series that they gave us. Don't worry, we're going to work some more on the fraction part, but you should be able to set up, all right, this what I'm putting in yellow right now, you should be able to set up any equation that I give you. See you tomorrow.